Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So, good afternoon and welcome. I'm Danielle Fisher from the Vibe research team, and I'm excited to have Sheila Carbondale joining us today. Sheila's in from the University of Calgary, where she's been a pioneer in research on information visualization and tabletops, and she's going to talk today about the joint spaces between information visualization, art, and tabletop design. With that, I'd like to pass it over to Sheila.
Right. And I don't actually, well, I guess I kind of do have to stand here for making my slides go forward. But because I'm sort of behind this, I'll have to peer out at you guys. It's one of the disadvantages of being short. So so I put this title, Walking the Line, though it is the first time that I've actually done a public talk talking about this space between fine arts and computer science. And so part of me is actually much more nervous than I usually am, because I think like, well, I don't know quite how this is all going to come together and if it would make sense. But I think that many of you actually have seen my work, and you've seen the papers, and if I just kind of, like redid that would be kind of boring. And I thought everybody actually knows that I have a dual background, and that maybe it would be the time to actually try and talk a little bit about how that works for me. So that's what I'm going to try and do. I have a art, design, and computer science background. Way more time spent being a student than one should ever do. I went to Emily Carr, where I did art, not design. And I went to Sheridan College, where I did design. Actually worked teaching fine arts for almost about 10 years. Had my own studio, did all that kinds of stuff. And actually came back and went to Simon Fraser and did 2 degrees in computing science, both an undergraduate and a PhD. And so with all of that, of course, didn't end up being a prof until moderately recently, like 2000. So this still feels to me like kind of new. And I did actually kind of, get sucked into feeling like I should be a little safe pre-tenure and kind of stay with the science thing in a computing science department. And, so it's only been in the last 3 years that I've been kind of looking more at how I can push this edge and bring it into what I do and that kind of thing, like trying to actually. So part of where I wanted to start is I actually want to talk about these terms that fly around, like what I actually think about what does multidisciplinary mean. And to me, a multidisciplinary endeavor is one where people of many disciplines need to work together for a common goal, but there is integrity within the disciplines. And I think a perfect example of that is the medical situation, where you have, your family doctor, your surgeon, your social worker, dietitian, all kinds of different people. They have their own expertise. You really need all of them, and you actually really want them to stay in their own expertise. It's where they belong. And this is what I think of as a multidisciplinary effort, and a lot of what we do in our society is multidisciplinary. And there's this other space called interdisciplinary, and that's kind of more common, I think, to the kind of space that we work in, where, you have a programmer and a designer and a human factors expert, and you bring a team together. I think it's like really common, like in theater, where the end result is a kind of melding of the skills. Not necessarily that the people change, but they're working together, like to put a play on where the skills of each are kind of bumping into and feeding off each other, and they're working in what I think of as interdisciplinary, between the disciplines space. And then there's this other space, which is what I kind of inhabit, what I think of as transdisciplinary, and you can sort of see the link, but it's where, you take the time to actually try and understand both worlds to some extent, so that you actually, at least to some extent, embody both kinds of expertise. And in education, up until now, mostly this is kind of an arduous path, kind of like the kind of thing that I did. It's sort of not actually something I really actually recommend people doing. But I think that for our world, there is this sort of huge spectrum from somebody who's in, like right at the end of like doing fine arts and design and just actually wants to have a little bit more technology program type savvy so they can at least actually tell when their programmer is pulling the wool over their eyes and telling them they can't do something when it's just they don't want to do something. They don't want to have a little bit more technological power. And where, a computer scientist might actually just like to know a bit more about colors so they can maybe make their interface kind of a little bit more sexy, a bit appealing in some way. And they're just kind of stepping slightly, but there's this whole space in the middle about, where the two come more together and what does one end up and where does that sort of change over and how does that work? And so there's two parts to this. And one is the methodology of how you actually go about doing your work. And one is dissemination, how you actually go about talking about your work. And I think they're really quite different. And I'm going to mostly today talk more about my kind of exploration of the blurred methodology space, but I wanted to have a little bit of talk about voice, the dissemination space. Because when I work in, and I do a lot of interdisciplinary work where I'm working with groups of people with more than one discipline, when one of the big differences to me is sort of what you want to do with the end result and how you want the people who interact with it to experience it. And if I'm in the science voice, all the efforts is to actually make it clear. Like ideally, somebody reads a good science paper, they can go back to their own place and they can reproduce it. If you've done a really good job, they could rerun your study if they want, they could re-implement your algorithm. You want to try and be clear. In fact, one of the reviewing questions is, could an intelligent grad student go from this paper? That's sort of one of the common things you want to answer. And for an artist, they definitely want to get their stuff out there. They definitely want people to see it, to experience it, to interact with it. But they want to raise the level of questioning in the viewer. So they don't necessarily want to, in fact, actually, if I try and write about it, they might say, you're spoiling the piece, you're destroying it, right? You're taking away all the mystery, right? So there is a tension here between, like, how people want something disseminated and who they want to disseminate, and whether me, thinking as a scientist would think it's being disseminated, right? Or whether it's just being put out. But they really want people, I don't know, you probably actually have used that word, problematize, which I hate. But essentially that's what the way, one way of talking about it is they want to take some issue and actually expose the problems in it so that people are sensitized to it, more aware of it, that it may actually influence and impact and change their way of thinking, right? So I think there's a lot of unexplored and unresolved for me differences in what the end voice was. But then as I went through kind of thinking about what I was actually going to say about blurring of the methodologies, I found myself less and less clear of which is what. And I think that I'm going to talk about it a little bit like as how I can see this as an arts methodology, but I think you're all going to say, yeah, I do that. We do that. We do that all the time. And I actually think that, there is this. We use both methodologies, but I actually think, like, there is a kind of richness to it. But I think that there is also a kind of fundamental difference, which, can be talked about as a difference between vertical and horizontal. And I think of the scientific methodology as being a vertical methodology. And I chose this image because I think of it as like, so if I'm advising a student to approach a problem, they say, hey, this is a really exciting problem, this is what I want to work on. I would actually say, okay, let's find out what's out there, what's been done, who's done what. Let's actually make sure that you have a really good understanding of what has come before you. And part of what you're doing is like you're kind of gathering all of the literature and all of your antecedents, your ancestors, your academic ancestors behind you, almost to give a momentum to it. Like I think of it as actually, getting yourself, where's my mouse, getting yourself, up into the crest, into the foam of the wave, so that you have this kind of momentum behind you. So when you take a step, once you know that, it'll be forward. That by the methodology itself, you know what's been done already, so that when you do something new, you'll be actually moving forward. And, this is a good methodology. This works well. We use it a lot. I use it a lot. So I don't want to actually be criticizing either. I just kind of think there is a richness of trying to actually look at both. And so if I characterize an arts approach, I think of it as horizontal, like that you have the whole world at your feet, that anything is part of your information, your inspiration. Anytime, anywhere you are, you could draw on in any kind of way. So I thought this was actually kind of a nice broad horizon picture. But so it's all about like learning how to think laterally, learning how to get yourself into a place where you haven't approached this problem from before. And I know that one of the things that I still use a lot of is the whole kind of contrary-wise approach. That if I'm thinking about something, what's the opposite? If I have a solution but I'm not happy of it, what's a non-solution? Because thinking about a non-solution will then have a mirror into the solution space that's somewhere different. Like, can I use playing between the positive and negative to find more places in the space than I had before? So this sort of horizontal approach is kind of like can you come from it from somewhere else? And I know when I was teaching fine arts, the best thing a student ever said to me was, I see the whole world differently now. Because this is all about observation and how you observe and how you're aware of your own reactions to what you're observing. And that all of that is where inspiration comes from. And I think that's like, I don't see any reason why we can't do both, why they don't both fit together. And I think that there's useful stuff to be gathered from both. And I also think that it hasn't been that comfortable for me operating in this space. And I usually find that whatever space I first meet somebody in, they kind of think that I can't really be very good in the other space. So, if I'm used to operating with somebody in the arts world, they'll think I must be a kind of compromised scientist. And if I'm used to operating in the science world, they say, but you don't really do art anymore. I mean, this...
Better than the reverse.
Well, I don't know. Anyway, so it's like... Anyway, so it hasn't actually been that uncomfortable, but yet I do think that it is, very rich. And I think, if I've got my... Remember, the next slide is, this is the gang at this point. All of my students have, though some of them are quite in the arts world themselves, that's still a relatively few. Most of them have come from a pretty solid science, or a very solid science background, but all of them in working in my group have started to actually, they're coming at least and edging in a bit, and that's having some understanding of this kind of transdisciplinary space. And part of the reason that I put this up at the front is I do want to, as I start getting into examples, these people are, of course, the reason why all of these examples exist. And I do actually include their pictures when it's their stuff, so you can see if I don't actually say them by name each time.
I have a question before you so earlier you were talking about the purpose of art. A lot of the purpose of art is about raising the question or raising the level of questioning in the audience that people are coming to. Do you see and there can also be a message, right? The artist or a concept or thought that's going on. Do you see that as part of raising the awareness, or is that
the message?
Yeah, or do you feel that
can
separate the rest? Okay.
Yeah, it depends on the artist. I mean, sometimes they're quite passionate about a message, some of the ones that I know, and sometimes they're not. They want the piece really actually to irritate, like to cause consternation. It's kind of to try and make somebody rethink some of their fundamental. I mean, there's a whole lot of art that actually these days that actually makes me feel really uncomfortable.
Do you feel like that the raising the question aspect is more fundamental maybe than the message to make a piece of art?
I think it would depend on the artist. For some of them, definitely. I don't think necessarily for all. And there is also, there's the whole blurring. I mean, I said sort of art and design, and I mean, there's the whole blurring between art and design itself. And those, you probably actually know, like they're two very different ways of thinking. And your question really is an art-flavored question, where a designer is much more likely to be swayed by, functionality or appeal or those kinds of things. So they want to, see more in that.
I mean, technical work, oddly enough, has the same dichotomy of there's work that is often really good and influential because it does raise questions, but it doesn't really come to great, crisp technical answers.
Yes.
Some people love that kind of work and some people hate it, so it was very interesting.
There is.
It's kind of funny because visualizations, Ben Scheimer often says, a good visualization raises more questions than answers. So it's very appropriate.
Yeah, it is. I mean, yeah, and this is kind of the only kind of slide that I have like this. And it's just partly like the kinds of things so I want to talk a lot about, I'll start with an example about a representational transformation. And part of the reason that I do InfoVis is when I sort of stumbled across InfoVis is it's kind of art in the science world. Take abstract concepts and you make them so other people and you can see them. It's kind of like, it's almost like some of the definition of art, right? It's like, so I kind of really attached to the whole thing of representational transformation and actually really like playing around with different kinds of ways of like doing exercises to try and enable that kind of a facility. But largely this is about observation, and I've just sort of picked out examples of work that you will all go, oh yeah, it's familiar work of stuff that you've seen that sort of has come from nature, from art, from other artwork, from everyday objects, from ideas and concepts, which is part of this kind of like horizontal approach. And then at the end, I'll end up talking a bit about planned observations, because that's part of where this real blurring has actually got really exciting for me. I come from the art world and it's all about observing, but there wasn't anything. I mean, see, this is the opposite thing. So in the science world, everybody knows you have to be inventive, creative, innovative, but nobody teaches you how. You got it or you don't. You pick it up on the way by yourself, right? And yet, they'll teach you how to observe and what it means to observe and how to, so they'll teach you that part. And in the arts world, they'll teach you how to be innovative, creative, and they tell you it's all based on observation, but they won't teach you how to observe. So I think this kind of like a nice kind of coming together here so anyway, I just go through a little bit through these examples. So the first one is a representational transformation. And I was going to just talk about keystrokes. So the idea behind keystrokes is, so much of our communication is digital these days. We've got this wealth of emoticons that are being developed because everybody knows that it's not personal anymore. When you wrote a hand note, the character of your handwriting, whether you were in a rush or whether you took care, that was all present in the note. Now people try and add that on because it's not in the typing. So we thought, well, let's just visualize the typing patterns, the letters and the rhythms of how you type, because that's got to do with those same kinds of things, your presence of mind at a particular time. So this representational transformation is actually pretty straightforward. It's based on the QWERTY keyboard, so it probably wouldn't work very well for people who are doing Dvorak or something like that. Just slightly perturb them so they use up the screen space better, but essentially the rows of the typewriter are there, the keyboard are there. And there's a line drawn between one letter and the next, and the fatness of the line depends on how slow it is. The slower it is, the fatter it is. It's a very simple representation of your speed and rhythms of typing when you stop to think and when you're typing fast. There's a couple other little things that are added in because backspacing is so much part of how this all works. So this is a backspace. It does take the leaf that you drew out, but it leaves a trace because backspacing is part of typing character. And if you repeat a letter, it didn't show at all initially, so these little white dots are repeating it. And they ended up calling this keystrokes because almost immediately people know where the letters are and how to actually play with typing and stuff like that. So people start painting with it. People started typing nonsense to each other, but making little paintings out of the pattern. So, yeah, these are examples, and I think I actually have, it's going to run? Yeah, a little bit of a video of just typing. Okay. So, another example. So, observing from nature. You know, what?
That you would send the animation, or that you would send the final picture?
We actually had it set up, and I don't think it ever actually made it onto the web. It was intended to, we wanted to make it like a little web app. And actually what it would do is make a little card so that the visualization of the typing, of the message, was the top of the card, or it was like a postcard. It would print as a postcard. And
So a static image, the final image.
the final image was static. Though you're right, actually, you know, that would be cool. It was, for all three of the students who did it, it was a side project. It was not, you know, and it was something that, you know, an idea that came up and they got all really excited about, and actually, you know, they did very quickly, and it was really fun. But then when it came to making it a little bit more product, it didn't happen, which happens so often. Yeah, so now you've actually seen most of this. This is phyllo trees. So, you know, it's inspiration from nature. That's part of that sort of whole horizontal thing. You know, sunflower seeds have this gorgeous double spiral pattern. It's actually got all kinds of wonderful properties. It's provably optimal if you don't know how many seeds or nodes you're going to get ahead of time, which of course the plant doesn't. But actually, you know, in InfoVis, we mostly don't know either. It's really good to be able to know exactly where to place the next one without having to disrupt your whole layout, and actually know that you have optimal use of space.
Is that an artichoke leaf layout too?
Yeah, I think it's not exactly. I think the artichoke leaf uses a different. Let me see if I get to the next one. So this is actually, you know, it's very, very simple, which was really nice because it means we can have like 200,000 nodes and it's still interactive. It's really, really simple. The first one is placed a certain constant out from the center, 137.5 degrees. That's the sunflower pattern. You know, n times 2, constant times root n gives you your radius. It's really simple. So you get all these gorgeous patterns. If you change the angle, and nature changes the angle too, you get different types of spirals. So you can have kind of characteristic spirals. We did a really simple tree layout, a la cone trees, right? But using these kinds of patterns to lay out the children instead of just a simple circle. And you end up with absolutely gorgeous and fairly readable trees that show pattern really clearly. So it's actually really kind of satisfying how gorgeous they are. And I think this one I have a little animation of. Is it going to animate? Come on. There we go. So this one I think is actually 200,000 nodes. But structure actually, even though it's really big, and it is in some ways too big, but structure actually comes through really well. And nature is a good idea, right? So that's phyllo trees. I think the next one is yet another tree. So this is an idea inspired from other art. So this is from Persian floral patterns. This is actually called shamseth. It's this concentric nesting of circles into kind of sun shape is, well, it's the inspiration for this. And we have yet another tree layout. So here's a Shamseth tree. But I'll step back a little bit and actually sort of explain what this is. This is actually a tree cut. This is not a whole tree. So this was, from the science side, this is kind of looking at WordNet, which is huge enough that you never load the whole thing in if you actually want to navigate it. You load a bit, and then you take a new part from a different route and you load some kind of bit so you can actually handle it. And even the parts, like if you load something under artifact, you may still have, several thousand nodes, right? I think it's over 75,000 nodes. So this is a context tree, right? So if you take that node, this is node focus. If you take that node, it shows children to 2 depth. It shows all of the ancestors and ancestors' children to 2 depths. So it's a tree cut. It's not a whole tree, but it lets you load the whole tree in. And now I'm actually sort of done this switch that my students accused me of, talking about it more from a science perspective, right? From what the problem is, what it does for a large tree. So you can actually load the whole tree and you can navigate around in the tree really easily. It animates really well, but it doesn't ever show the whole tree. I don't know, yeah. This is brand new. We just actually sent the camera ready paper up on Friday, so it's brand new. But there's a small part of WordNet under artifact centered on the node hose. But once again, gorgeous patterns. Once again, we actually use the phylotactic layout because by looking at how many nodes we had to put in the children in one area, we can choose an appropriate angle will actually make them fit into the same size. So, different patterns actually work from different angles. So.
Sorry, maybe you're about to illustrate this. What are the concepts at the periphery illustrate? Like what's happening at the edge?
This dark one. This is the root.
Right, but in the case of hose is the example, and fire hose and airline hose are inside.
So do you know how WordNet works?
No.
No. Okay, I wouldn't actually be able to tell you what hose. This is an ISA hierarchy, human created, of the English language. So, a fire hose is a type of hose. A hose is a type of, and I'm not sure what they characterized hose as. I would have to look it up. By the time it all the way gets out, the only other label that we've put on is artifact at the outside. You could actually put labels all the way down through its ancestors.
So artifact is the outside word.
Is the root of this particular branch. Actually, WordNet is anchored for everything at entity, that all words are a type of entity of some sort. That's how they categorized it. It's not an algorithmically done ISA tree. It's a human done, but computational linguists actually use it a lot.
Thank you.
Yeah. So that was, for everyday objects. And so here's something that I know everybody has seen. You've probably recognized what I'm going to show next, right? Which is now not that new. You've all seen that. But this whole, if you want to actually share, if you want to spread information around, what do we do in the physical world? We've got all these kind of conveyor belts and sushi boats and things like that. So we just thought that we'd stick it on a table, right? And actually found that it fundamentally changed how people browsed to have this sort of rapid serial access. And we found that actually when people were doing the same tasks without currents and with currents, without currents, they divided the task into sorting and assembling. And you'd even actually hear them while they were assembling saying, oh, we might have seen a better picture for that, but they didn't want to go back to sorting. And when they had that easy kind of access, they'd switch back and forth. They'd disassemble and then say, oh no, we had a better picture. And they'd go look for the better picture. So I think arguably people might do better quality work. From concepts, so this is more actually stepping into the actual art world, like thinking I have an idea that I want to express. So this first one is memory and code. So this is 2 people, Holly and Uta. They were, at that point paired theoretically. It's this interdisciplinary. Uta was one of my students, and Holly is a fine art student. And they were looking at manifesting memory somehow on the tabletop in an interactive way, some way that would engage people. So they made all of these different cells. Each cell has a memory. Anybody who walks up at any side of the table, you can actually get a soft keyboard and you can type in your own memories. So when it was actually up in a gallery, people would come in and they would type their memories in and they'd get their cells. But these cells had half-life, so gradually over time, if nobody read them, they'd kind of fade away. So people would come back and see if their memories were still there, if people had been interested in them, if their thoughts were still there. Also, the cells had the ability to concatenate, so they would join and merge, and then there would be. So sometimes, different thoughts and different memories would kind of get elongated. So it was interesting. It was actually really interesting to us because both in what I'd experienced at that point, going into galleries with interactive art pieces, and I'm going and I'm trying to figure out how to make these pieces, like what's happening, what is this interactive new media art piece in this gallery, and really hard to figure out what they were doing. And I think partly it was because everybody had been trying to figure it out like me, and most of them were broken because people had done terrible things to them. But it was just but nobody was interacting with them. Because people are used to going to a gallery and just kind of, you know what it's like when you go to a gallery, you kind of look at what's on the wall, maybe you read the caption, and you go on. And you've got maybe, 30 seconds to 2 minutes for a piece, kind of what the average length of time that somebody gives it. It's not very long to attract somebody's attention. So one of the really cool things about this is people wanted to do this. People wanted to do this, they wanted to come back. In fact, actually, we ended up putting double-sided sticky tape around the edge of the table to try and keep too many hands off it, to try and actually put people off, to slow some things down, because we needed to actually slow the interaction down. And it's so on the science side, it actually started this whole thing about, okay, what is intriguing? How can we take things like InfoVis into a public space and make it intriguing? What was intriguing about that? What would actually make somebody walk up and spend 10 to 20 minutes with it instead of its kind of usual 2-minute maximum? And can we actually use that to enrich a gallery museum type experience? So this is actually, starting a whole direction for me of InfoVis in public spaces, like how does this actually work? So the next piece was end up being an installation in the Glenbow, which is a local gallery. They're having a traveling show of Emily Carr. And if you know Emily Carr as a painter, one yes. She's a very well-known Canadian painter, unfortunately less well-known out, but she painted at the same time as the Group of Seven, but very much her own style, though you could see of that genre. Very much about Canadian nature, but West Coast instead of Ontario. And very much about trees. So the first part, the visualization had 2 parts, and one part was this kind of cross-section of a tree, where each tree ring represents a decade of her life. Each bubble is either one of her own writings, one of her paintings, one of her sketches, a photograph of her, a critique of her. It was some kind of information that would enrich the context of the show that was there in the gallery at the time. So you could browse through it and see, other paintings and know what time they came in her life and how people had discussed them. So that was kind of one half of it. The other half is this more conceptual tree, which was like grouping in a more sci type, tree type way. The type of discussion that had gone on around her critically. There's different colored branches, and depending on what you chose there, this would show the branch that related to the piece that you showed there. And if you go in and choose something else in this branch, it would actually then open up a different thing over there. So the two are kind of linked, and I have a little bit of a video. So this is actually at the gallery. You can hear you can't really hear what people are saying, but you can hear that other people are talking about what they're exploring. You can see that touching one here, it comes back into that one. And there was two things about it. So it was a kind of tilted tabletop, so you could come up to it easier like that. But what was happening on the tabletop was also projected really large on the wall adjacently. So that you're walking past it, you would actually see the interaction on the wall. And this was actually fairly well interacted too. We actually just this fall published, and this was there for what, 3-4 months? So she spent hours and hours and hours, because we couldn't videotape anything, sitting at the back, taking notes, watching how long people interact with it, what kind of people. It was different between ages. So they're sort of like getting back into like making this science. And this was the piece that was a finalist in the Canadian New Media Awards. It was one of 3 finalists. So here we get into this whole planned observations thing. So here I sort of come starting to do this, like well used to thinking that like, you know, observations is like, that's where I get my inspiration from. And here's this whole community that like, you know, will actually formalize observations. Because I never actually talked to other people about where my observations came from and where my inspirations came from. And I think actually probably some of my most cited work at least has been from this kind of like planning observations and actually watching and thinking and taking, you know, like seriously looking at the data in different kinds of ways with actually even some of the same kind of terminology that comes right out of the art world, like looking at the data with different kinds of lenses, like, you know, understanding kind of what kind of, because you can't not bring a bias to it, so like, you know, understanding what your bias is so you can use that as a lens and talk about it that way and actually see what actually comes up from the data in that kind of way. So this planned observations or observation for inspiration is totally like works for me. It's a lot of where I come from. The first 2 here that I'm going to just show really briefly is the whole beginning of the territoriality stuff. We did lots of watching people on regular tables, all kinds of studies. Stacy spent hours going through videotapes, counting, like dividing up into different segments and counting everywhere that everybody touched, making activity plots and looking at the different kinds of patterns and, you know, relating them to human territoriality and looking at developing this whole kind of way about like how human territoriality kind of manifests on tabletops. A little bit different, not exactly the same, but lots of similarities and lots of kind of useful information about how coordination and negotiation happens over space when you have a larger space. This is actually, I like this, because part of like this is like you can observe on so many different levels. So you can observe about the task. So here they're doing a planning task, you know, like how long they're taking at different kinds of spaces, what kinds of things they do first. Do they put where the rooms first? Do they put the big pieces of furniture? You can think about the task, what's happening in the task. You can learn about the task. But if you do that, what you would be able to get out of that, and you could probably get some really good inspiration, but you'd end up making software that's for floor layout, because that's what you're learning about. But so what we were looking at is, you know, tabletop coordination, like more than one person sharing a table and how that worked. And so one of the things is like, from counting all of the things, the dots where people would touch across the table, like far away from themselves, they were really, really, really few. But they did exist. But see, one of the sort of really neat things to observe is, so see here we have 2 examples of people actually reaching across into other people's space. And look at the other people. Look at the similarity of the hand posture of the person in the red shirt and this person here. This is this kind of moment out of time. People don't object, it happens, but there's a kind of pause in activity. And it's almost exactly the same way they use their hands. There's something here that sort of is both like saying, it's okay, but I'm in suspended animation. So then the person who's doing this reaching is really quick about it. But this information, like I'm in suspended animation, that information doesn't happen in software. And that's kind of part of what keeps the person polite. Like they'll say, excuse me, and they'll apologize again as they come out. But if they swipe their mouse across, or like some kind of cursor across underneath where people's hands are, they don't have the social cues to help them be polite. So I think there's a whole lot of interest in tabletop territoriality. I think almost everybody who thinks about tables thinks about this in some way. Yeah, this is actually the first software that we did post-tabletop study. I mean, one of the things that we saw is that all of the tables were flexible, and all of the territories were flexible and mobile. You know, this private and personal group, but there's also these kind of storage territories. You know, that's where you put your book and your lunch bag when you're working with your friends. And what we figured was most missing was storage territory. So that's a storage territory.
Perfect. Cool.
And these are people who had never seen it. At that point, of course, hardly anybody had tables, because this is now 3 years ago, right?
They do pretty much.
So 4 years ago. So I think we'll go on. I'm going to run out of time here. So this is the orientation study, and maybe I should go through it a bit quicker. Similar kind of study, people doing puzzles on tables. I very clearly remember after we gathered all the data, Russell coming into my office and going, I see people making puzzles on a table. What is there here? Right, but what we ended up, like through looking and looking and re-looking, is this whole kind of thing about how orientation is actually used to communicate. But one of the key observations that led us into this is this particular thing. One of the things that, so we talk about group territories and personal territories as being established by how you orient the objects. Then we knew there had to be a time when they decided on group orientation, and how did that happen? And we were actually kind of lucky that it was actually in most of our videos, because it was right at the beginning, and lots of the groups actually had decided what group orientation is as they were sitting down. And you can probably even remember this, like you can say, oh, I'm good at reading upside down, let's just do it your way. Like that's usually something that people were very proud of. It was usually decided almost before they were actually seated at the table. But these guys here, I'll show you this because this is so amusing. They were, the arrow in this
5 by 5.
is indicative of what will end up being group orientation.
What an experience when you read upside down. Right. Yeah, shall we? Can we do this?
So thank goodness for outliers, because they took so long doing it, we actually could see what was happening. But then you could see when they're talking about it, and they were the only ones who took like a protracted, and it was, you know, they were laughing and they thought it was kind of hilarious. Most people actually did this really smoothly, happened really quickly. Yeah, so that's, but this whole orientation was used for coordination, for communication, as you guys I think are all well familiar. And so the next thing, and this is kind of part of where we're at right now, and we've got at this point all kinds of data, not all of it analyzed yet, and kind of in the middle of all of this. But it's, and in fact, actually I think that to some extent, you know, like, well, Petra has been here recently, and we're kind of thinking, okay, let's actually do this for real. Like if somebody's actually going to work on the table, what do they need? And we've gone back to observing people at work, observing people doing complex tasks, and observing people doing simple tasks, actually going out into the real world where people are actually working, and bringing people into the lab where we do these kind of planned observations. And there is a sort of, and it's still, like I say, like in this part, I think that the sort of observation for inspiration is kind of already there. We're already kind of like seeing how this comes together and how you actually can actually do real applications. But the fullness of the data analysis is not there yet with this data. We're still looking at it. We've got quite a lot of it. Yeah, this is just actually saying people actually, these are not from our, but people really have real lot of data that they still really look at paper. These are just images. This is actually my two students hamming it up. This is the study. Actually, that Petra designed. I actually really liked this study. She wanted everybody to be experts, and you know you can't get a whole lot of experts really easily. So she actually found a data set on manners, on where it's polite to run and where it's not polite to run, where it's polite to burp and where it's not polite to burp. And you know, we're all kind of experts on this, right? So, and a bunch of stats about manners and people's opinions about manners, and so we could ask them some questions about, because part of the impetus for this is, we're going to try and put information visualization on a table. All of the stuff that we have about how people do visual analytics comes from people actually already using software. So how do we actually know that that's how people actually really do it? That's how people do it with the software. And software actually, yes, we all know, is kind of opinionated. It kind of tells you what you can do next and what's easy to do from where you're at. And so you do it, as you learn the software, you do it the way it kind of doesn't get in your way so much, right? So we again wanted to go back to pencil and paper, give people visual information, simple tasks, about data that they actually understood and would find amusing, and just see how they solved it in small groups and how they actually did that. And this was actually, was it this year at Chi? Yeah, so this is just recent. So I'm not going to go into the details of this, but essentially most of the categories of the different kinds of ways that we group things really relate to everything else that's out there in the literature. That's not too surprising. These are kinds of the things. The one separation that she made that's not common is strategizing and discussing collaboration, because she thought that it was interesting for us that we're trying to make collaboration tools to when they're actually talking about how I'm going to work with you instead of what we're actually going to do. So that's the distinction between those two. I think the rest of them are ones that are familiar. But the interesting thing about this is, temporal sequence, or one of the interesting things, but this is definitely one of them. So we had groups of 1, 2, and 3, and she had 6 or 8 groups of each category, so that's quite a few groups. There was no repetition even from one group to the next, in temporal sequencing of how they would solve the problems. So, and it's also really clear, and this is those kind of, that the ability to have insight and then jump over several steps was how, groups became efficient, or, this was an important part of being able to work together and being able to work well together. So this whole notion of actually you got to free up temporal sequencing is the first place that we kind of looked at how do you actually incorporate that into software. So she's looking at tree comparison things on tabletops. And I think here I have a little video. Yeah. So here you see these two people are actually initially working quite independently. And our table's got quite a bit of space. Each of those is 1400 by 1280, so there's quite a few pixels. And you'll see where this person here on the right suddenly finds something that's interesting. And you can watch. So you can see when you're observing, you can actually see when the moment is that somebody gets interested and they say something, right? And then the important part, or what we're trying to work towards, is that it can become seamless from when they're working independently to when they're working together. And that the software kind of supports both, and it has the flexibility to provide them with the space they need for both, right? And I have actually kind of blurred back into talking about this from a science perspective. So there's two things that I wanted to end up with, and there were all kinds of other examples of projects that I could have talked about for these kinds of things. These are just a sort of set that I talked about. But one of the things that I want to kind of leave with you is this whole idea that we have this kind of fixation in our community that empirical work is about validation and verification, where for me, empirical work is about inspiration and design. And I really enjoy and find this hugely rich to do the majority of the empirical work that I do before I design anything, to do observation for design. So that's, I think, kind of maybe my main message. And this other one, I've talked about this all today about working in this transdisciplinary space, of actually kind of working within oneself with some understanding of both worlds. this is, I also work in a lot of interdisciplinary projects. So these are all student interdisciplinary projects where it's pairs of an artist and a scientist working together. And well, just there's a whole wealth of other things there. But I think that actually this space is just as interesting and just as worth exploring. And that's actually where I was going to end up. So.
So perhaps I'll kick off the questions. That last slide you showed us, made me as an InfoVis person sort of cringe a little bit.
Yes.
Because for the first time in this entire presentation, you've shown me bits on the screen that aren't data. Everywhere else, everything you've shown me was someone manipulating something for information. And, that was a warm and fuzzy space for me.
This is, I mean, I can talk to you about these different projects. Some of them actually have some data kind of aspects to them. But no, these are interdisciplinary art science projects where, so there's this whole other kind of discussion that you can have about if you have an interdisciplinary space, what does it actually mean if it's in balance and like both the artists and the scientists are equal? Can that actually work? Nearly always somebody ends up taking the lead. Somebody ends up kind of being in service of the other, that it's primarily science that's happening and the artist is helping them make better science. Primarily art that's happening and the scientist is helping them make better art. Like, does balance actually work? If so, it's difficult. It's not common. Usually you're in one space or another. In the interdisciplinary classes that I have run, there has definitely been a tendency for it to be art projects. I think that, by the time somebody has done 5 or 6 years of computing science education and they're in a situation where they can do an art installation, it's like, woo, right? And they're all for it. And that tends to be what happens. Though there are some interesting things. So this project, won the Governor General's Award. It's kind of interesting idea, and it's sort of data. It's so the idea was taken from, when you go and you have your photo taken in the mall. So they wanted to make it kind of like a photo booth, but instead of having your photo taken, it was to watch a little video clip. And they said, okay, so what is it? How do you actually choose what videos, what movies you're going to rent, what movies you're going to see? You choose them based on your friends' opinions. Said, so let's not actually give them any title or tell them anything about the actual movie. Let's show them a person's reaction who watched the same clip before, right? So on the outside, you can see different people watching different clips, and you can go through seeing different reactions, and and you go and you make a choice, and you go inside and you see some video clip. So they're using the data of, people's response as little video clips as part of their art piece. And, it was interesting as an art piece. Annoyed people a lot. But that's in this space of people wanting to, problematize this whole thing about, does that actually really work? Do you actually really want to make your choices based on your friends' opinions? Is this actually a sensible way for you to make your choices? That's what they kind of wanted to make people start thinking about. And so they had achieved what they wanted, in making people relook at what's a common practice in society, right? And that was, their piece. And I could talk about all of them like that if you want. I mean, they're all actually, all the ones that I chose on here actually I think are really quite interesting.
Can you talk about the drawing?
This one? Okay, so these two young women, they said, okay, what we want to do is we want to make an interactive piece that encourages contemplation. I thought, oh yeah, right, okay. I thought good goal. Go for it. If you can do it, I will be impressed, right? And they did. So they built this thing that looked a little bit like a well. They filled it full of water. At the bottom of the well, they made a sculpture that's a reproduction of, the type of dome that's in certain types of temples, Persian temples, sort of a nested 3D star pattern. So they created one of these, they inverted it, so the bottom of their well is this gorgeous multi-curve nested pattern. They had a projector up above projecting through the water onto this. Several variations of the traditional type of filigree patterns that go with these types of domes. And the usual kind of vision, motion sensor, camera stuff happening, so that the camera is watching what the audience is doing. However, what they triggered it is if the camera catched any motion, the animation would restart. So if you want to see the full animation, you have to be still, right? And, people figured it out, but, so I was only actually there at the opening for the gallery for this one. So there's always somebody new coming up and people going, shh, don't move, right? And they'll actually be doing this with their hands or something like it was. But it was really interesting to see that people figured it out and were trying. There was a whole sort of community effort into trying to get it to be calm enough so they could see the full pattern. And I just think I thought it was pretty cool. I thought it was a very cool piece. Katune Etemad and Leah Rogers.
So I'd like to get back to your tabletop work. In particular, what I noticed about your observational studies is that most of them seem to be based on paper prototyping. Right?
Yeah.
So
we're taking out the very...
It's very nice because you get started very quickly and you don't have to worry about implementing things.
Yeah, we didn't have a table when we started.
Right, exactly. And it's a great technique. So one interesting thing, a consequence of doing things that way is you might start into your software thinking about various physics metaphors for your interactions. And
Absolutely.
Right, and like on the one hand, that's been, I think, one of the great strengths of most of the stuff that we've seen in the tabletop software is you have this sort of tangible, pseudo-tangible
There is
aspect.
some kind of aspect that's close to tangible. I completely agree with you.
Yeah, but some of the stuff that you showed after that, where you actually finish out the software prototype, breaks through that wall, right? And you're showing these huge data sets, relatively huge anyway, compared to the paper prototype. And so you're now collapsing spaces, you're doing all this kind of stuff, and I'm wondering if you could comment on this transition from, you have to be doing all this stuff on a computer for some reason.
Yeah, okay.
Right?
Well,
so that's one of the powers of moving to these interactive tabletops. But then on the other hand, how do people react to that? Do they, what's sort of the consequence of sort of giving some of that away, the tangibility?
okay, first of all, I think that I do think that, and there is stuff that I didn't show that we're kind of looking at, force-based interaction. I think the stuff that you've been doing is like really cool. I really like both the last two things that I've seen come out of your group, the shape touch and the bringing physics to the table. And I think this is like a really hugely exciting direction for tabletop interaction, and that it is getting much further into this tangible, this in-between tangible. And so I actually think this is great. But I also think that, like we do in the long run, or I think I want in the long run to actually, or in the long run, I guess I even initially thought that I wanted a table, like I did my PhD in screen real estate, like in how to get big information onto small screens. So when I had the opportunity to get a piece of equipment, I thought, I want a bigger screen. I want a bigger screen and I want more resolution. And I thought about that even before I was thinking about like tables, right? But I thought that's what I wanted to do, and because the whole purpose initially was to get back to big information. And I didn't do it initially because when we first got our table in 2004, 2005, the interaction wasn't really there for big information. And I didn't feel like the interaction was really there at all. It felt like we just needed to like start to rethink this. And part of me actually thinks that going back to big information like we have in the last year instead of going on with new different types of kind of like force-based interaction, is maybe the wrong point to have a hiatus in that direction. And yet for me, it's been kind of like regrounding in the initial goal of like actually thinking, can I at this point actually think about real applications? I do know that the biologists that we're working with right now, it's completely flipped around, that if we will give them access to our table, because we actually have their data on it, it's not for them like a study or something. It's a privilege to have access to it. They will give us any amount of time and they're not paying any attention to us. They're like muttering away to themselves and doing stuff, which is really fascinating for us. But so I would think that we're a long way away of having what one really ultimately wants to have in the way of tangibility of interaction on tabletops, and this feeling that you can actually get your hands actually into the data, which is, I think, where we actually really want to go. But at the same time, coming back to actually having big information on the table and seeing that there are people who actually really want to use it is, I don't see where I am at right now as the end point. I think of it as like a reconnection I needed to make to information visualization on the tabletop from doing what was largely kind of HCI on the tabletop.
So it seems like one of the big problems there is how do you take this kind of intuitive, tangible interactions that people gravitate to and put them on big data, make them work with big data.
Yeah, well.
Without putting a slider
so it's
or
a good thing that we still
thing on, yeah.
Good thing we still have work to do, right?
What's your sense like when you're showing your work to people, maybe the biologists or just random visitors in the lab? Like what makes people gravitate to your systems? Like why do they?
I actually think
what excites people about these devices in your opinion?
I actually think that the resolution is a big issue. I actually think that.
But wait a minute, the resolution on most of these devices is terrible.
Well, it's not on ours. We have a 4-up with, so we have like 6 megapixels on our table.
Okay.
I would still actually like to go higher, but it's getting close to the resolution. It's actually pretty much what you have on an average high-quality screen. So we have 1,400 projectors instead of, I would like them to be 1,600, but they're 1,400, and they each do a space about that size. So we have, the whole table is quite big. It's about 4 feet by 5 feet, but it's 6 megapixels.
Do you know what the DPI is off the top of your head? I can't do that math in my head.
Me neither.
Okay.
It's in some of my papers somewhere. I could, yeah.
But I don't know, that's not the answer I was expecting, right? Because you've done a lot of work before you went to high resolution.
Actually, that's not true. We went straight to high res. I mean, when I first got the money to buy a table, I went and I looked at some tables. At that point, Simon Fraser had one, UBC had one, Stanford had one, and I went to see the Merle gang at, right? And I came back, actually, truthfully, quite depressed. Thinking like, oh, I can't do InfraVis on any of those devices. And actually had this whole negotiation with the grant agent to let me build my own. And so the first table that I built was 2 1280 projectors on this same 4x5 screen. So it's quite big, but the one I have now is more than twice the resolution of the first one. But still, the first one was like 3 times the resolution of any of the other ones I saw in the labs at that point. So we were already actually higher res. So, and I think that a lot of the appeal of the everyday person as they come in is pictures are crisp, they look good, they're pleasant to look at, you don't have any blur, you can read the typing. So all of those things matter, right?
But have you done the experiment where you compare it against?
Because I don't actually have a low-res table. Actually, now we have
No. I was going to say the other possibility in that matrix, and that's like a high resolution conventional display.
Ah, yes, but that's different. We have actually done some sort of, I would say not formal, not published, but we've done parts of studies of like looking at vertical and horizontal. And so in vertical, just like John Tong's original paper said, that people tend to work serially. Like even if it's a group of close collaborators, they take turns. There's somebody, even if they're at a whiteboard, so it's not digital, there's somebody pontificating, and then there's other people, and then there's be a change. And if you have a table, everybody thinks it's a free-for-all. All the hands go on at once. And it happens immediately. It happens in public places. When SMART had their table at CSCW 2006, David Martin is there actually, making some pronouncements, and he's walking up, putting his hands on the table and doing something. No, right in the middle of like everybody feels like this is a table. Tables are for everybody. Tables are a kind of unifying place. So it's different when it's a table. It's like equals the playing field, it levels the playing field, literally, right? So I think there is that about tables. I do know, I know that the community kind of goes around saying, where's the killer app, where's the killer app? And I've been kind of always sort of perplexed about this, because my experience when people come into our lab is they all say, I want it now. Even some of our like really kind of not very together demos, right? So I think that, and I do think that a lot of the demos that are out on other tables, the interaction's a little bit different. We're in a kind of equivalence class in some ways. Some differences here and some differences there, but so it's not like I think that our applications are that different. So that's why I kind of didn't want to say, oh, we're doing these absolutely different. That's not true. There's, we kind of like, the tabletop community does like all the rest of the community, like this, this sort of does this, but we're kind of all coming up together, looking at much of the same issues. So I guess that's why you've got this sort of immediate response is, well, one of the things that is different about ours is the resolution. SMART doesn't like it when I say that either. Yeah. They kind of go like, it's difficult to do, it's unwieldy, we have one in our lab, they don't have, it's not the response they want to hear either. In fact, they would like me to run a study and prove that I'm wrong. and yeah. Though I think that
our Surface team would probably co-fund it.
Yes, right. Because if you could actually show that it didn't matter, it would be much easier. Because actually, like the Surface is actually now, I think it's really nice. It looks good. It's smooth. We actually finally have all the touch that you want. There's a whole bunch of like really, really nice things about it. But the resolution is low, and it's small. I want size and I want resolution, but I love the multi-touch. I think it's fabulous, and I think that all the stuff that you're talking about with physics and what the killer app to me will actually end up being is that people really can feel like not that their data is like this long way away from them, but that they have their hands right in the data and they're manipulating it, and they haven't had to go into a cave where they've got all this encumbrances and they're tied and tethered. And actually, I think caves have the same problem. They're all low res. Well, maybe not all. There are some now of these big, huge, mega projects that I think have lots of resolution. So I'm not going to, they exist, that's for sure they exist. And I haven't been there. I should actually try and get there because supposedly they're a fabulous and absolutely amazing experience. But I actually think, I think the resolution is important.
Cool. Thank you.
I think if there's no other questions, we'll thank the speaker once more.